Okay, so we're going to start by grading the balancing equations worksheet. Page 3. So this is page 3. You should have each coefficient's worth a half, and then each substance is worth 1 point. All right? So 1, 2, arrow, 2, 1. 27, 2, 1, arrow, 2. 28, 1, 2, arrow, 1, 2. And then 29, remember, substances are worth 1, so it's 2 Al plus 3S, arrow 1 Al 2S3. 32 is 4, 3, arrow 2. 33 is 4, 1, arrow 2. Next one is understood, right? So Fe Br2 plus 1 Cl2, arrow 1, FeCl2 plus 1 Br2. 35, 2 in front of HCl, 1 Zn, 1 ZnCl2 plus 1 H2. 37 is 1, 3, 2. 38 is 1, 2, arrow 1, 1. 39, 3 AgNO3 plus 1 Na3 PO4 plus 1 Ag3 PO4 plus 3 NaNO3. And the last one is 2 Al plus 3 Cl2, arrow 2 AlCl3. So then write your score at the top out of 36. Now we're going to look at day 2. So 12-2. It's out of 55 points. Remember, all these problems can be done because we have a balanced equation. You have to have a balanced equation each time. We took the time to balance in our packet. That's making it easier for each one. So I'm going to go through this with you, okay? So you should have 32.2 for your given. First step here is molar mass, 1 over 171.3. If you had like 171.5, it's minus a half, right? Like the value is wrong. Mole ratio is 2 to 1. 36.5 is the molar mass of HCl. Your final answer is 5.63 grams of HCl. Like, what if I got the wrong answer, but I have 3 sig figs? It's only minus a half, right, for the answer. If you're taking off points, make sure you tell me why you're taking off points. If it's sig figs, write SF. 17, 15.28 grams of H3PO4. 1 over 98.0. If you don't have the 0.0, it's minus a half. Why? Because that is going to affect your sig figs in the end, right? This mole ratio here is 1 to 4, and then 284.0. If you don't have that 0.0, it's minus a half. The answer here is 11.1 grams of P4O10. If you just have 11 grams, it's minus a half for sig figs. 18. You start with 15.55 grams of AgNO3. Divide by the molar mass of AgNO3, 169.9. Mole ratio is 1 to 2. Molar mass of Ni is nickel, 58.7. Your final answer is 2.69 grams of Ni. 19. You start with 23.4 grams of Ca. Divided by the molar mass of Ca, which is 40.1. Mole ratio is 1 to 2. Molar mass of O2 is 32.0. You got to have that 0.0. If you don't, it's minus a half. Answer is 9.34 grams of O2. 20, 32.45 grams of O2 divided by 32.0 grams of O2. You got to have that 0.0. If you don't, it's minus a half. 2 to 3 for the mole ratio. 58.5 grams of NaCl gives you 39.5 grams of NaCl. Right? How many you missed at the bottom? Yes. This page is different because now we're looking at particles, right? Either we're like starting with particles or we're given particles, and then we're ending with particles or, right, mass. So 10.0 grams of H2 divided by 2.0 grams of H2. Do we agree that that's 2 sig figs there? You got to have the 0.0. If not, it's minus a half. 2 over 2. And then we multiply by Avogadro's number, 6.02 times 10 to the 23 molecules of H2O, which gives you 3.0 times 10 to the 24th molecules of H2O. Any questions on that? 22. Oh, wait. If you forgot the power of 10, it's minus a half. What if you accidentally solved for grams because you didn't look at the problem, right? It would be minus 1 here, half for the answer, half for the unit. 22. 92.45 grams of Na divided by 23.0 grams of Na. 1 over 4 for the mole ratio, multiplied by Avogadro's number, 6.02 times 10 to the 23 molecules of O2. Gives you 6.05 times 10 to the 23rd molecules of O2. 23. You start with molecules. 1.6 times 10 to the 23rd molecules of CH4. Divide by Avogadro's number. 2 to 1 for the mole ratio. Molar mass of O2 is 32.0 grams of O2. Because of the 2 sig figs of your given, your final answer should only have 2 sig figs, 17 grams of O2. Any questions on that? All right, 24, 56.8 grams of Zn. You're going to have 65.4 for the molar mass of Zn, 2 to 3 for the mole ratio, 6.02 times 10 to the 23 molecules of H3PO4. That gives you 3.49 times 10 to the 23 molecules of H3PO4. Last one, 256 grams of CuNO3, 2, times 1 mole over 187.5 grams of CuNO3, 2. Mole to mole ratio, 6.02 times 10 to the 23 atoms of Cu. That gives you 8.22 times 10 to the 23 atoms of Cu. So then you should have a score out of 55. So now we have new values to fill in from our balanced equation worksheet 3, right? So in your homework packet, everybody should have their homework packet. And what we want to do now is turn to number 26. Right? So I have my homework packet. And we're going to go ahead and fill in these numbers. So for 26, you should have 1, 2, 2, 1, right? 27, 2, 1, 2, and so on. You're going to do that for the rest of the packet. So go ahead and do that. And then when you're done, we'll continue with the notes. Okay. All right. So we're looking at page 3 of notes today. You need a calculator, periodic table, your notes, maybe a different color for sig figs. So today we're looking at molar volume. It is the last thing in our stoichiometry island diagram. that we have to learn about. We know about molar mass. We know about Avogadro's number in particles. Now we're going to learn about molar volume. Molar mass, like if students thought about what those words meant, it'd be easier to understand what's going on, right? So molar mass is the mass of 1 mole of that substance. Molar volume is the volume of the gas of 1 mole of that substance. It's very different though, because molar mass, I got to use the periodic table. Molar volume, in a sense, is easier because it's always this value, 22.4 liters. It's always 22.4 liters. You got to know that number. Like, do students give me different values for that on the test and on the quiz? Of course they do. They'll give me like 24.2, 44.2. It's 22.4 though, okay? So make sure you know it's 22.4. When it comes to this, though, it says at STP. So it has to be a specific standard temperature and pressure. But it's always 22.4 liters. So that's what we're going to look at today. So, 2 things influence the volume of a gas. The 2 things that influence the volume of a gas are temperature and pressure. Temperature and pressure. So then we need to compare them at the same temperature and pressure, which would be standard temperature and pressure. Standard temperature and pressure is 0 degrees Celsius for the temperature and 1.00 atm for the pressure. ATM stands for atmospheres. We're going to learn more about that in chapter 13. Okay? It's abbreviated STP. So the nice thing is, in the problem, they got to tell you that this reaction is at STP. That kind of gives you a hint that, hey, I could, if I wanted to, use 22.4 liters for the volume. Okay? 1 mole is equal to 22.4 liters of any gas at STP. So I could have helium, I could have nitrogen, I could have oxygen. It's always 22.4 liters if it's at 0 degrees Celsius and 1 atm. So now I know that these 4 things are equal. The mole, right? Molar mass, molar volume, and particles. And I am able now to use all those tools for stoichiometry. Now, there's a typo though. Not a typo, but the way that we set these up, I set them up, it's incorrect. So I want you to look at here. On the balanced equation worksheet, I put CO2 and then H2O. But on here I have H2O first. So do you see how this isn't balanced correctly? So I got to fix this. So instead of this being H2O, do you see how this should say CO2? And this one should say H2O. So you have to make those changes in order for this to work correctly. So I apologize. You have to have CO2 here and H2O here. And then what about this one? Do you guys see how I did the same thing here? So I got to change this to CO2 and this one to H2O. So it's not that we didn't balance them correctly. It's that I wrote the products in a different order on the notes. And so I don't want you to have the wrong coefficients because I didn't write the products in the same order as I did on the balancing worksheet. So now we're ready to do the molar volume, okay? So if 107.00 grams of acetylene undergoes combustion at STP, so there's my STP, right? What volume of carbon dioxide will be released in the atmosphere? So I'm going to start with my given. 107.00 grams of C2H2 set up my workspace, and that's going to be equal to volume of CO2. What unit should I put for volume? Liters?
Oh, yeah, that.
Liters? Right? Liters of CO2. And so now, right, if I'm stuck, I could look at my stoichiometry island diagram. I'm starting with mass, so I'm up here. And I want volume, way over here, right? So I got to go from, in the end, I always have to use the mole-to-mole ratio to go from one substance to a completely different substance. So I'm going to go from mass to moles, mole to mole, mole to volume. So the first step I'm going to do is cancel out grams of C2H2. And remember, the only thing that I know with molar mass is that what goes with the mole? 1, and the other part is using the periodic table. So the molar mass of C2H2 is 26.0. Grams of C2H2 cancel. Now is where I can use the mole-to-mole ratio. So I put moles of C2H2 on the bottom, and I want moles of CO2 on top. So this is where you can put a circle or a heart around your mole ratio, right? I'm going to put the coefficients from the balanced equation here. So 4 goes with moles of CO2, 2 goes with moles of C2H2. So then now, moles of C2H2 cancel, and I'm going to put moles of CO2 down here, liters of CO2 up here. 1 always goes with the mole. And then we said that that new number is 22.4. 22.4 always goes with liters. Okay, so now we put this in our calculators. This one has 5 sig figs, 3 sig figs, unlimited for the mole ratio, 3 sig figs for 22.4 liters. So I'm going to round to 3 sig figs. So if we put this in our calculators, we're going to take 107.00 times 4 times 22.4 divided by 26.0 divided by 2. You should get in your calculator 184.369238, but I only need 3 sig figs, so we should have 184. Everybody okay with that? Okay. So now, we're doing the last problem. How many liters of O2 at STP will be used when 132 grams of methane undergoes combustion? So I start with my given, 132 grams of CH4, and I want liters of O2. Once again, oxygen's a diatomic, but another hint would be that I look at the substance in the balanced equation. O is not written by itself, it's O2, right? So now I need to cancel out grams of CH4. That's molar mass. Mole of CH4 on top. 1 goes with the mole. Molar mass of CH4. 12 plus 4 is 16.0. Next thing is the mole-to-mole ratio. Mole of CH4 cancels down here. Mole of O2 goes up here. CH4 is 1. O2 is 2. And then I need to cancel out moles of O2. So I put liters of O2 up here. 1 goes with the mole. 22.4 always goes with liters. This is my mole-to-mole ratio. I got the coefficients from the balanced equation. So now we check our answer, or we put it in our calculator. So go ahead and do that. Checking our sig figs. 3, 3, unlimited, 3. So I take 132 times 2 times 22.4 divided by 16. You should get 369.4 or 6. And how many sig figs should we have? 3. So what's our answer? 370 decimal, or 3.70 times 10 to the second liters of O2. Okay, so what's our homework? Our homework is day 3.